Next, let's look at the solution part. All right. This time we take a different view on insertion step. We want to borrow the experience of the insertion step as our starting point. When we start, let's look at the insertion step first. We have to do modification. Yeah. So let's recall that insertion step. Yeah. Why take a different view? Because we can get a new idea. When you take a different view, then you may find some new insight. Yeah. And a new solution could come from that new insight. Yeah. All right. Yeah. So let's look at the insertion step. This is a typical insertion step. Yeah. The left subarray already ordered. It is sorted. Yeah. And we need to insert a new element V into an already ordered array. That's the typical insertion step. Yeah. Yeah. So you know the detail, right? You need to compare. Yeah. So we do comparison with the last one. If it's smaller, another comparison until we find the right position. That's a typical insertion step. Okay, yeah. Yeah. All right. But can we treat this V element as one element array, a special case? Yes, one element array, right? We can treat it as an array. So this subarray only has one element. Yeah, special case. Yeah. But if you look at it in that way, then we have two subarrays. Left subarray ordered, right subarray very small, but it is still ordered. Can you treat the insertion step as a special case of the merge step, merging two ordered arrays, right? Yeah. So we can borrow that old experience because they're closely related in this way. Yeah. Merge two ordered arrays. Yeah. All right. Yeah. It's sorted. Yeah. Although the size, not quite balanced. One is very small, one is relatively big, not quite balanced. Yeah. It's okay. Yeah. But we can extend it, right? Yeah. When we start this single element subarray to extremo, but we can extend it to a normal ordered array, right? Yeah. Okay. New interpretation. Yeah. Two sorted arrays are combined to get a new sorted array. And that insertion step is pretty much gives us the basic way to merge two sorted arrays. Yeah. But we need to do some modification. Yeah. All right. Yeah. Okay. So the new view, merge two sorted arrays for a new sorted array. Yeah. Every time we find the right position for one element, or every time we put one element in place. Yeah, remember the terminology. Yeah, in place. Yeah, put one element in place. Yeah. All right. Yeah. Okay. Yeah. Data size. The first array has k elements, but the second array has one element. That's for the insertion. step. All right, not balanced. Yeah, because if the data is not balanced, based on our experience, usually that property would result in poor worst case. Yeah, poor worst case. If the data is distributed in some unbalanced way, that usually result in worst case. That's something we want to avoid. So when we have a chance to distribute data, we want to distribute data evenly, as even as possible, in order to avoid worst or poor worst case. So that's some experience, the experience we have, when we work on real world problems. Yeah. All right. To improve performance for the worst case, we use some balancing principle. Yeah. So yeah, because this is some principle, right? It's not a theorem, so we cannot prove it. Yeah, based on our experience, we just realize when the data is distributed in a balanced way, we can get a better solution. All right. Yeah. Try to make two subarrays of equal size. Yeah. When you have a chance, when you have the freedom to do it, then you should do it in a balanced way. If you do not have the freedom, then you just take whatever you have. But here, it looks like we have the freedom to choose how to split our data. So we will take advantage of this freedom to split the given data as even as possible. Yeah. So the next round, next page, we will do divide and conquer. But when we do that divide step, we try to split evenly, split the data evenly. Yeah. All right. C.2, merge operation. Now we look at the detail of the merge operation. Yeah. All right. How to achieve balanced subarrays. Yeah. The divide step. First, we need to split the given data. We have freedom. Nobody told us which way to split, right? Yeah, we have freedom to split the data as we like, right? Yeah, here we will take advantage of that. Okay, idea: whenever we merge two subarrays, we make them of equal size. Yeah. Sometimes it's not possible of equal size, but as even as possible. Yeah, because sometimes you have odd number of elements, right? You cannot split evenly, right? But we will split. One subarray has just one more element than the other one. Yeah, that's the best we can do. Okay, yeah. So here, so we will do it that way. I draw this diagram to show you the even split way for divide and conquer step. All right. This whole line segment represents the original array. Yeah, this many elements. Yeah, we do divide and conquer. The first time when we make split as even as possible, so yeah. At the most, one difference, right? Yeah, could be. So the difference of the sizes of the two subarrays could be 0 or 1. Yeah, yeah. That's the as even as possible. Yeah, difference of the sizes 0 or 1. Okay, even 0. Odd, difference of the two sizes 1. Yeah. Yeah. All right. So the first split right in the middle. Okay. Yeah. one subarray could be one more than the other. Yeah, that's fine. So we just try the best we can do. Okay, yeah. Divide, then conquer. All right, conquer. But conquer means we make each subarray sort. But when we do the sorting, we need to apply divide and conquer another round. Okay, yeah. So another split in each subarray as even as possible, like this. Okay, yeah. After 2 rounds of split, you can see, each subarray has approximately quarter size of the original array. All right, yeah. But still, we need to conquer each one by divide and conquer. So another round split. All right. So you can see each subarray, its size becomes smaller and smaller. Yeah. But we need to stop somewhere, right? We cannot split forever. Yeah. Stop splitting when each file, each subarray contains one element. Yeah, that's the end. One element, you cannot split anymore, right? You have to stop it. One element. And one element, it's already sorted. It's ordered. One element, when we treat it as a special subarray, it is already ordered. All right, so then after that many splitting operations, we need to reverse the process, right? We need to merge all these subarrays and eventually to get the whole array sorted. Yeah. Next, let's look at the merge step. Yeah. When we do merge, we merge 2 adjacent subarrays. 2 adjacent ordered subarrays. Yeah, we assume they are ordered. Okay, we merge 2 adjacent ordered subarrays. Yeah, to get larger ordered subarrays. Okay, that's the first round. Next round, merge again 2 adjacent ordered subarrays to get even larger ordered subarrays. Yeah. Another round. Yeah. So round. Yeah. Another round. And finally, at the end, we merge 2 ordered subarray to get a whole array sorted. That's the idea of this merge sort. Okay, yeah. So using this diagram, you see the high-level idea, understanding of this new sorting algorithm. Okay, yeah. So you can see if we can find that merge solution, then using this divide and conquer way, we can get a whole array sorted. Yeah. But we need to figure out the details of that merge step. Yeah. So it's missing. Right now, we need to fix that detail part. Yeah. All right. Yeah. Hope it can avoid poor worst case performance. Yes, because we do the even splitting, right? So we try our best to avoid unbalanced data distribution. Yeah. And we hope to avoid poor worst case performance. Yeah. Later, you will see, yes, yeah, in this way, the merge sort definitely avoids poor worst case. Yeah. So later, I will explain that part. Yeah. All right. Now, the critical missing piece, main step, merge step. If we get get this merge step, then we're done. Yeah. So then the whole merge sort is there. Okay, yeah. So, but that part, that piece, that part is critical for this